So I want to start with creating a dog. And as you can see, we're using a Eclipse IDE. This is one of my favorite IDEs for Java because it helps show a lot of the errors that you might have. So what I want to do is I want to create a new project. So what I'm going to do is I'm going to go to this top left screen and I'm going to select Java project. And let's call this exotic animals. So we've created a folder. What I'm going to do is actually delete this because I usually don't use modules. And as you can see, we have a list of Java things that we can use or import into our program. And in our file structure, we're going to put all our stuff inside this source folder. So what I'm going to do is actually create a new package. And this package will contain all of our related files dealing with this exotic animal store. So let's call it com.dataflow.exotic. Finish. And within this package, I want to put all the actual files. So I'm going to do new file. Let's call this dog.java since this is what we'll be starting with. And we have our dog.java folder or file. So what I want to do now is create the class itself. So what I want to do is create a UML diagram first and kind of picture what methods and what variables I want to have within my dog class. So I actually wrote it out right here. And you can see that we have dog as the class name, and we have the variables that we'll be using here. And these minus signs and plus signs resemble whether it's going to be a public or private class or method or variable or whatever it might be. If you guys don't know what public and private are, I'd recommend looking it up, or I can make a separate video on it. But for now, I'm going to be skipping what it does and just going straight into the implementation. So we have the public or private class or method or variable. We have the variable names up here, and we have what the return value is going to be. So a string return value is going to return something that has alphabets within it. For example, integer is just any number, and then double is a number that it has a decimal in it. So like 3.25, and integer is just like 1, 2, 3, 4, 5, 6, 7, 8, etc. So these are the variables, and these are the methods. So you can see that they're divided by these lines. So the methods are down here. So we're going to have a constructor. A constructor is a special kind of method, and this is actually a typo. This should be dog, because the constructor should have the same name as the class itself, because the constructor is what will be ran when we run the class without using any methods. And this will make a lot more sense when we actually implement it. So just know that this is a typo. My apologies. This should be dog. And then another method is calculate monthly financing. This will be basically when someone buys a dog, we want to provide them with monthly financing, and that if the dog is $300, we want to be able to split that amount over, like, say 12 months, so that the owner doesn't have to spend $300 immediately, but they can spend money over increments of time, so that they can actually afford it if they need it. And that will be a method that we'll have. So for each user, we'll calculate monthly financing for a specific dog. And then we have calculate monthly financing with a tip. So we want to, in this exotic pet shop, we have it so that people can actually tip the people that help them find the dog or pet or animal they need. So here we have a parameter that we're going to pass into this method that basically shows that we want to give the person some sort of tip. So let's go straight into it. So this is going to be a class called dog, and all of our methods and everything else that we saw here is going to be within this class. So we're going to have these variables, string or name, months to finance, and price. So let's do that right now. So since these are all private attributes, since you see these minus signs, we are going to do private string name, private double price, and private months, int months to finance. So these are the variables. One question you might have is, why do we have private here? Private modifier means that you cannot modify this value outside of this class, but rather you have to change it within this class. But we have these three variables, and then we have the methods. So remember that a constructor is a special type of method. So this is our constructor. We're going to have it be public, and we want to pass in these variables. And this will make sense later on why we do this. So we're passing in all the variables that we've instantiated. And we also want to have a way to change these variables. So when a user does something like dog, we create a new object, dog, that has the name Jerry, and he's worth $300, and we give the user 12 months to finance. So these values that we pass in have to be saved into this class dog, because we're going to be using those values in other methods that we're about to implement later on. So there has to be some way to equate these variables to the variables within dog, and that's where this keyword comes in. So we're going to do this dot name equals name, this dot price equals price, and this dot months to finance equals months to finance. So this is basically saying that these variables are going to be put into the values of the variables instantiated here. So let's say that this is called price 2. Then we're going to have an error here that says price cannot be resolved or is not a field. So this is because this price this price 2, which was originally price, has to be price 2. So now this variable will have the value that is stored in this variable, and values are stored within these variables by creating new objects. If that didn't make sense now, it'll make a lot more sense when we actually implement this. So we have the body of our constructor, and this is basically all we really need. So now we can create the methods. So we have calculate monthly financing and calculate monthly financing with a tip. So let's do that right now. So this is going to be a public, since it has a plus sign, public, and it's also going to be double, right? So public double calculate monthly financing. We're making this double because prices can have decimals in it. And let's return. So how do we find monthly financing? Well, it's really just price divided by the number of months to finance. So return price divided by months to finance. And that's all we really need for that method. Now let's create another method, and let's have it have the same method name as the one we just created, financing. And we're going to have an error that says duplicate method in type dog, which is fine. Duplicate methods are completely normal in Java programming, and we'll see why it's a good idea to have it in your files. So now, instead of having no parameters, we're going to actually pass in a parameter, and we're going to do double tip, because tips can be decimals, so we're going to make a double instead of int. And within it, we're going to return. What we're going to do here is, rather than returning price divided by months to finance plus tip, right? Because monthly financing will be or sorry, that's not right. It should be price plus tip, because tip isn't a monthly thing. So tip to the person plus the price of the pet divided by months to finance. So that's one return method we can do. But what I was going to mention once I realized there was a typo is that say that we give users a monthly tip, rather than doing price divided by months to finance plus tip, we can call calculate monthly financing and then add tip to that. So it would be like return calculate monthly financing plus tip. But note that in this condition, we're not really doing that because tip is an upfront value just like price of the pet is. So that's going to be our method. And according to our UML diagram, we've covered all the methods and variables we need to instantiate. So that's all we needed to do. And we're going to have an error here that says declared package, because we didn't declare a package, does not match the expected package. And this is because we put it under com.dataflow.exotic. So what we want to do is add this package declaration. And one nice thing about Eclipse is that these errors can be solved through the suggestions that are provided. And we also have another error that says the value of the field dog.name is not used. So this is going to be a warning rather than an error, which means that we can still compile this file and still get something. We're going to keep this as so because we don't really need name at the moment, but just being aware that this is not used is something that might be important. So now that we have the file itself, we want to create a unit test. So a unit test is a way to prove that the methods that we have instantiated within this file are working the way we expect it to. This is super important for like industry, for example, where we want to, when we give our code to other people, we want them to know that the code that we've written makes sense and it does what we expected it to do, so that they don't have to deal with the bugs themselves later on. So let's do that right now. In the future, when we create new Java files, I'm going to create the test folder first, or the test file first, because we want to have a test-driven development approach to our files, in that we want to create the tests first and then create the methods based on the tests that we want to create. But for now, we're doing it the opposite way, where we're creating the file and then we are creating the test. So what I want to do is right-click on this file, and I want to do new JUnit test case. And we're going to have a ton of options here. So Juniper test is basically JUnit 5, so we're going to use the latest version. Source folder is fine. And I want to actually check mark all of these method stubs because I want to kind of explain what each of them do. And we can ignore this. We can just finish. And it's asking to add JUnit 5 library. So it's going to add a library to our source folder. That's fine. Kind of have to do that. So as you can see, we have our JUnit 5 folder, and we have our dogtest.java. And as you can see, we have these method stubs. So what this does is that for each test that we create, we want to say we want to create a new object instance before each test that we do. Then we put that object instance instantiation within this @before each method stub. Say we want to do something after the test is ran, we want to put it in the @after each for each test. Say we want to do something before all of the tests that we write are written. So let's say we have @test that does something, right? So @BeforeAll will do something before these two tests are written. @AfterAll will run after these two tests are done, and then @BeforeEach will run once before @test, and then run again before this @test. So for now, we actually don't need these BeforeAlls and and after each. So I'm going to delete those and keep the at before each because we'll be using that. So let's delete this fail. Or actually, before we do that, let's run this and see what happens. We're going to have a failure because we're going to get an assertion failed error, not yet implemented, and that's exactly what's here. So if we delete this, we will get a passing test because there's nothing in it. So the first thing we want to do is test for each of the methods. So I want to test for calculate monthly financing and make sure that it does what it's supposed to do. And in order to do this, we're going to be using assert equals, and we're going to be comparing an actual value and an expected value. So let's rename this test. Let's say test calculate monthly finance. And this is okay to have a super long method name because we want to be as specific as possible with our unit tests. And then we have to also define actual and expected. So if we go back to our dog.java folder, we see that our what we want to happen is we want price of the dog divided by the number of months we provide the owner to finance. So actual is going to be simply the method itself. So calculate monthly financing. But there's one problem though before we even move on from here is that we need to have this method running on an object or an instance of the object. So we can't just do dog here because it'll give an error. Cannot make a static reference to a non-static method from the type dog. So we need to create an instance of dog and then test that a method that we instantiated here with that instance. So let's do that right now. So at before each, we're going to create a private dog Marty. Let's just call it dog Marty. And we'll set it equal to a new instance of dog. And we're going to put in some random values. So we're going to call its name Marty. It's going to be valued at $300.25. And we are going to finance it for 6 months. So we're getting an error here, which is saying that value local variable Marty is not used, which is completely fine because we haven't used it yet. So now we can actually do Marty.calculate monthly financing. And since this is a double method, double is to calculate monthly financing, we're also going to make actual double as well. So we have an error here that says Marty cannot be resolved. So I did this on purpose to show you that you have to make this variable visible to everything within the class. So in order to make it visible, we have to actually, we don't even need this private variable. We just need to say dog Marty. And here we just delete dog and the error will be resolved. So now Marty is visible for each test as well as the at before each method stub. And we want to make this private because we don't want the variable, we don't want users to have access to it outside of the file. And now that our error is resolved, we can now do the expected, and let's make this double. So expected is where we want to actually make our test that ensures that this method is running right. So it's obviously going to be price divided by months to finance. And these variables are not going to be referencing these, but rather they're going to be referencing local variables that are written within our test. So let's actually declare double price. And we want it to be the same value as the value that we passed in here because we want the values to be equal. That's what assert does, is it makes sure that actual and expected have the same value. So double price equals 300.25, and then double months, or actually months to finance is an int. So int months to finance is equal to 6, so that it matches this number. And now we can do double expected equals price divided by months to finance, and we have our assert equals. So this test will pass if assert equals is true, and we're going to do that right now. And as you can see, it's a success because it's a green bar, and this method has successfully passed. Let's say we make it fail. So let's call it 301.25, which is different from the price here. And we're going to have a fail right here. And you can see an assertion failed error expected this number, but instead got this number. So it will tell you what the value of each one is if the value doesn't match the actual or expected. So let's change this back to 300.25 so that the test pass. And let's go on with creating a test for void test calculate monthly finance with tip. So this is going to be testing our tip method. And just like before, we are going to have a assert equals that compares actual with expected. And since actual and expected are double, we're going to have double actual equals and double expected equals. Now what we want here is we want to reference Marty. So now you understand why we have it under at before each, because we don't have to put this in this test and this test before we run this. We can just put it in at before each. So this will run before this test, and it'll also run before this test. So we can do double actual equals Marty dot calculate, and we have recommendations here, so we don't have to type it out. Let's choose this one, and then let's put a tip in here. Let's say that we give the person a tip of $30 for helping us find the dog. Now our expected is going to be price plus tip divided by months to finance. Now these are going to be errors because we haven't declared them, so let's create some values for it. Double price equals 300.25, double tip equals 30 because we're passing in 30, and then int months to finance equals 6 because we have 6 here. So now we have these values defined, everything's done, and we can run it one more time. And now instead of one test passing, we have 2 tests passing. We have the test calculate monthly finance with tip passing, and then calculate monthly finance also passing. So these tests are now passing. So the last thing I want to do before we end this video is go over negative testing, which is testing for values that we might not want but might go through because we want to account for all values. So for example, if we go into dog.java, price should always be greater than 0. It should never be negative. Similarly, months to finance should never be negative because we can't have negative months and we can never have negative price. So we want to account for those values. So what I want to do is create another test called test negative months to finance. And I don't want to create a test that tests for negative months and negative price because that's bad practice. We want to focus on one small thing. So we can also create a test later on that tests for negative price, but for now let's do negative months. And let's make let's do a assert equals actual expected. Now, one problem we will have is that we want to use the Marty instance, but the problem is that these values are positive, but we want to test for negative. So we're actually going to create a instance of Marty within the test, or any new person. So let's just call the dog Jim equals new dog. Jim is the name, same price. And then we're going to, instead of having a positive month, we're going to have a negative month. So let's do -2. And this is going to be an error because we need to create a local variable Jim. So instead of having it here, let's do private dog Jim. So Jim is right here. And we want to have double actual being Jim dot calculate monthly financing. And we want to have double expected being some error. So let's actually make it 0.0. So 0.0 resembling that this is an error. And let's see what happens. So this is going to be a failed test, but for a reason we don't want. Expected -150.125, but was 0.0. So what's actually happening is that when we put in a negative value for dog, we're actually getting a value for the monthly financing, which is something that we don't want, and that'll actually break the program, because we want it so that when the program runs an invalid value, we want an error showing that this is not a value that we expected and we're not going to run this. So this means that we need to change it within the dog file itself. So what I'm going to do is go into monthly financing and say if price is less than 0, or, that's the or symbol, months to finance is less than 0. So if any one of these two variables is a negative number, return 0.0, right? And if it's not negative, then it'll just return this return value. So if we go back into our test, instead of expecting -150, we should now expect 0. And we'll do that right now. So yeah, the error has passed because this is now, actual is now 0.0 and expected is now 0.0. And for the brevity of time, I'm not going to go over creating the test negative price to finance, but obviously you should know that that's something that we should test for, and is something that's important to take into account. So these are called negative tests because we're testing for values that we don't want, and we're making sure that when we input these values that we don't want, that we're getting the output we expect, which is 0.0. So that's the first part of the series of videos I'm going to create on Java. So I hope you guys understood unit testing a little bit better, as well as how to convert a UML diagram to an actual file, and also understanding constructors and how to create methods for your class. Please let me know if you have any questions. I'm going to be continuing this series. So a quick preview of what I'm going to do is I'm going to create a new file, and we're going to be creating a panda.java class. And after I create this class, I want to create a test for it. I'm going to have different methods for it. So hope you guys enjoyed and understood the concepts that I went through. Let me know if you have any questions, and hope to catch you in the next video. Peace.